So I want to go ahead and explain the ear. We've been talking about different receptors for bringing in sensory information into the body. The ear actually, most people think, does hearing, but it actually does a couple of other things. It does equilibrium also. So let's go ahead and start with the anatomy of the ear, and then we'll talk about where the various functions happen. So the outer part of the ear is the first part. So the ear is actually divided into three parts: outer, middle, and inner. Let's talk about the outer ear first. So the outer ear is basically this part here. It's what we think of as the ear. It's divided into two different parts: the pinna, which is simply a collection device, and yeah, bigger does help, or dogs and cats that have ears that can kind of turn towards sound, that helps too. And then sound waves go in through the collection portion, the pinna, and it goes down a part that we often clear out with our swabs and so forth, and that's the auditory canal here. And so this is simply non-tangible. It's sound waves coming on down here. And then we come down to the second part of the ear. And the second part of the ear is called the middle ear. Let's go ahead and see if we can use a different color here. And the middle ear is fairly small. It's just this part right here. And the first part of it is the eardrum. So as sound waves come in, they hit the eardrum. Another word for the eardrum is tympanic membrane. It's Tympanic, tympanic membrane. And tympanic are like a drum. Sound waves come in, and then they hit the drum, and it starts vibrating. So what actually is happening there is something which is not really tangible, like sound waves, get converted into something which is more physical, mechanical waves. So things actually start moving. And the tympanic membrane, or the eardrum, is connected to three small little bones, which are called the ossicles here. And the ossicles are the malleus, which is the hammer, the anvil, which is the incus, and then we have the last one, which is stapes, which is the stirrups. And let me go ahead and see. I think I've actually spelt those out for you. Here they are. So malleus, which is the hammer, incus, the anvil, and stapes, which is the stirrup. And it's kind of like that game Mousetrap, where one thing hits another, and then a ball rolls down, and then something jumps, and so forth. So the tympanic membrane vibrates, and this causes the malleus, the hammer here, to go ahead and start hitting the anvil. And the action of the anvil then moving causes the stirrups, the stapes, to pull back and forth. And what you're actually happening here is mechanical waves, and the whole purpose of this thing is to increase the intensity of sound, amplification. And I think it's something like 30 times that the sound waves actually increase in intensity there. So you definitely don't want an infection of your middle ear. In order to prevent an infection there, we have kind of a safety valve tube, which is the eustachian tube, which is connected with the throat. And so fluid can be drained there if it has to be. And it has a little flap at the top there, which if there's too much vibration, too much pressure changes, that flap can actually close. And that's when we get that discomforting feeling where we kind of pop our throat, try to swallow and so forth in order to open up that tube there. So that's this guy here, which is draining stuff down there to the throat. And now we come into the third part. And the third part there is the inner ear, the most important part of the ear here. And their inner ear kind of looks, if you look closely here, kind of looks like, oh, that's a snail. And the snail is actually divided into three different places here. You got the antennae of the snail, which is the semicircular canals. You got the shell of the snail, which is the cochlea. And then you have the body of the snail, which is the vestibule here. And I think I've kind of written them down here too. And these three guys actually do three different functions of the ear. So most people think the ear just does hearing. Yeah, it certainly does. That's the cochlea. And the cochlea is connected to the brain through, surprise, surprise, the cochlear nerve. which takes information on hearing to, I think it's the temporal lobe of the brain. But the ear also does two other things. It also is responsible for balance, and there's two different types of balance. So you have the vestibule here, which does balance, and that does what's called static balance. Now, static balance means our position. So we know if we're standing upright or leaning, or if somebody grabs us by the legs and pulls us upside down. But it's also got the semicircular canals, which do a type of balance called dynamic, right? And dynamic tells us how we're moving. So if you get an infection of the inner ear, you often lose your balance, get that vertigo feeling and so forth. It's really, really bad. Those guys are established to the brain through a different nerve, which is the vestibular nerve. So that's doing balance, and cochlear nerve is doing hearing. Couple of other things I just want to point out here. You have two other connections here. I may have to just erase this a little bit so you can kind of see what's going on here. You got the round window and you got the oval window. So I just want you to let you know what those guys are. The oval window here is really just a connection between the ossicles, the bones of the middle ear, and the snail-like device here, the vestibule of the inner ear. And the round window here is kind of like, little pressure valve to let out pressure from the inner ear if things get going a little too much. So that's kind of the anatomy of the ear. The last thing I wanted to talk about was then how does the ear translate mechanical waves into electrical? So we had sound waves coming in, then we have mechanical, and then going through the nerves, we have electrical up to the brain. So let's just talk about that just for a moment here. Let's talk about the hearing, first of all. So that's taking place in the cochlea. So let's review what's going on here. Sound waves are collected in the pinna. They're translated down through the auditory canal. They then strike the tympanic membrane, right, where they're converted into mechanical vibrations. And those are passed through the ossicles, which amplify it. And then what happens is that the ossicles then cause movement of fluid inside the cochlea. Now, there's a part of the cochlea called the organ of Corti, and this has the receptors in there, and they're called hair cells, and they actually look like hair. And so what happens is as the fluid moves over the hairs then start to wave back and forth and vibrate, and this causes electrical signals, or what we call transduction, that goes down the cochlear nerve into the brain. So hair cells inside the organ of Corti, that's kind of what we want to remember. So that's how hearing works. And what about balance? So let's talk about static balance first of all. That takes place, as I said before, in the vestibule. And what's happening there is you have hair cells again. And there are little rocks that are attached to them called otoliths. And as we move our position, those rocks pull down on the hair cells, and that sends information down the vestibular nerve. And dynamic, so that takes place in the semicircular canals, and that has fluid again. And this fluid rotates around those kind of round antennae of the snail, and they go past hair cells once again, and that causes more information to go down to the vestibule. So, hair cells. Hair cells is what the ear contains that's doing the two different types of senses of balance and hearing.